happens if you drop Alka-Seltzer in a thing of water? 3 states of matter, liquid, solid, and gas. What is this?
Solid.
What is this?
Liquid.
And when you put the solid and the liquid together, what does it produce?
Gas.
Gas.
Tiny bubbles.
What happens when you have a buildup of gas? Don't answer it.
Oh, get him down! Get under the table, guys! Get under the table!
Run for your lives! I think it was a special kind of baby bottle nipple because it doesn't have a hole in it, so it's not squirt magic. Look how much gas. You guys saw how much gas was generated right there. That was all carbon dioxide gas that was generated by that Alka-Seltzer.
Alka-Seltzer, plop, plop, fizz, fizz. Oh, what a relief it is.
What do you think would happen with this kind of a setup? Got a film canister and some water in it, and I'm going to put some Alka-Seltzer in it and cap it. What do you think might happen? Cap it off. Just turn it upside down. Wait. Fill this thing about halfway up with water and put a quarter of one Alka-Seltzer tablet in there. We can experiment with some things. We can try warmer water, colder water, half an Alka-Seltzer tablet. What are some other things we could change?
Warmer is one of the things that we should change.
So what's working more? More water or leaving a lot of space in there?
Space. Where'd it go?
It's only went away above that tree.
It's a Mentos. It's a little minor right there. Hey, I'll shake it, Daddy. Oh my God! 1, 2, 3. That was fun.
Carbon monoxide. You remember what mon means? Like monomer versus polymer?
Uno.
It means uno. Mon means one. Carbon dioxide is what gives your Coke its fizz. This bottle right here is apple juice. Just plain old apple juice. And this bottle is vinegar. And in this little tube is baking soda. And this reaction is going to generate a lot of carbon dioxide gas, right? Through this tube, this carbon dioxide gas is going to come over here into the apple juice and carbonate the apple juice. Okay, here we go.
What if you tried to see what it tasted like and then it bubbled up and go right to your nose, your mouth and your nose? Well, yeah, kind of connected.
Just let that go for a while.
Tiny bubbles make me warm.
Baking soda, this is just some tissue paper, and all I'm going to do is kind of wrap it up, make a little Christmas present, kind of fold it and fold it again, that kind of thing. See what I just did? So that's step 1. That's what you're going to do first. And then you're going to put it in a bag, and with a partner, this is one that's going to require some teamwork, pour some vinegar into the bag, and as quickly as you can, get it zipped up, and then step back,
Put it on the ground.
and wait for what is going to happen to happen. What do you think might happen? Make some predictions.
It's going to do our left. No, put on you. Mike, it's finished. No. Jacob, how would you react? Get back, it's going to blow. Or totally annihilates itself. Get it right over it. Here. I can't. I'll play. Solo!
Tiny bubbles.
So I just went to the bathroom, and it was good that nobody had flushed yet. So I got some just regular old water right out of the toilet.
But it's
And
yellow.
these are specially engineered maggots. You guys know what maggots are? Like when a fly lays its eggs, it kind of grows the larval
It's what
form.
rolls
So
it
these aren't disgusting, they're just maggots.
They're disgusting.
What's disgusting about maggots and people?
Hey, can we, hey.
Genetically engineered to clean sewer water, toilet water, kind of pee poopy water, all that. So all I'm going to do is just kind of add some of these specially genetically engineered maggots to this. You can see them just start scrubbing. Can you tell how they just start traveling all around? Definitely smelling better. I don't know why you guys are so grossed out. But those maggots are a good source of protein.
Ew! That is not. That's pee. No. Pee has poison.
Tiny bubble.
It looks like raisins. Do they look like raisins or do they look like maggots?
Carbon dioxide gas doesn't want to stay in solution. If you just took a lid off of this, it would get flat. It wouldn't be bubbly after a while. If you look at raisins, they've got all these little tiny dots all over them, and they're wrinkly. They have a lot of like dents and crevices, right? They're not like.
I'm watching them.
Here, when the carbon dioxide forms on the nucleation side, it becomes less dense than water, so it rises up here and floats. And when it gets to the top, some of those bubbles bounce off and come out here into the air, and so it becomes then more dense than water, and so it sinks.
Tiny bubbles. Make me warm.
Remember how the raisins have all those dents on them, all those dots? If you looked at some Mentos under a microscope, you would see little tiny dents, radiation sites. That's where the carbon dioxide can experiment around with things. We change a variable to see what can we change to maybe have some science experiments.
Like
What else can we change?
putting wax on the window.
More or less Mentos. So this, I think this will hold about 10. You can try 7, 5, 2.
Back in.
There's something else I thought might change the reaction. What about temperature? I think temperature might make a difference. Almost boiling hot. Coffee water. Heat one up. What do you think about different brands? Maybe the more expensive Diet Coke brand would be different than the cheap
Diet's less
Sam's
messy.
Club. That's the reason for the diet. It's just regular Coke. Sticky. Experiment. You might graph out your results.
I have Mentos.
Pretend like this wall is a graph. See all the lines of the bricks? 9 Mentos versus 2 Mentos. Give us a mark, set, go.
Mark, set, go. It's a waterfall! It's going out of the side.
Which one went higher? Heat it up. It's almost room temperature. Hold hot. Give a mark, set, go.
Go! Set, go. Spewed out of the side. I told you.
Tiny bubble. Tiny bubble. Make me warm.